Great. Hi, everyone. Looks like we don't have an intro demo today. So let me make sure I got all items in front of me on my other screen. All right. So let's go ahead and get started. Hi, everyone. Welcome to Python Fundamentals Part 3. So this is the third week of our Python series. We have been learning about some tools and some basics for Python syntax. So we're going to continue that today. But this class would be a little bit different, especially the first half of the class, because we're going to introduce the concept of object-oriented programming and how to write a class in Python. So this would be a little bit different class in the sense that, this topic is pretty involved, and especially for the first time, it's a little bit of different coding paradigm. So that's why even the full class, the 4 hours, 4 to 5 hours, may not be sufficient in some sense, because there are so many concepts and details that we can cover. But the most important stuff that you may encounter week to week, if you start working on actual Python projects and see open source, will be covered in this class. And then that will be kind of a kickstart for you if you want to get more familiar with this topic. You can actually build on top of that. So okay, so let me actually review some announcements. So first of all, interactive. To make the class interactive, make sure you use all the resources. So please put your question in the Q&A whenever you have a question or need clarification at any point. So this class would be, a little bit. I need to moderate it a little bit better, because especially the first part could, get very long, and the discussions could basically extend. So my request to you is that please, if you think your questions can be addressed through Q&A and our TA can help, that would be great. If not, then we have a couple class activities for this part. And while people are thinking about those problems, then I will go over your questions, and feel free to raise your hand and we can discuss further. So the other thing is that we will again have assignment review session on Thursday, multiple choice questions, some coding problems. Hopefully you found the previous ones helpful. So this is going to be kind of the same format, a little bit different, because the coding questions will not be graded anymore, will not be corrected, but there are still good questions to go over. And then use your resources. So I realized that someone's asking for the link to files. So I already shared that, but it seems like the history of the chat is not visible. So I can actually try that again to share the links. So here are the links to the slides I'm putting in the chat, and should be visible by everyone. So here are the link to the notebook, and the link. There's also a sample small text file which I'm sharing here, which we will use for a reading file on the. Let me actually go to the agenda slide. So here's the agenda for today. So again, we have 3 parts in this class. The first part will be all about object-oriented programming. And after the break, we continue those concepts of object-oriented programming. And after that, we're gonna learn about custom sorting functions in Python and exception handling. In the last part of the class, we are going to talk about file handling, how to read and write to files. And then we're going to learn about JSON module in Python as well, and how to use it for serializing and deserializing text or basically strings to a JSON file. I think that's pretty much it. Let me know if there are any access issues or if there are any questions. But let's get started. So one thing before we go ahead, so if you're coming from a different programming language, you may find some of the definitions and the way the functions are designed and the way we define these concepts for class writing a class might be different, and it might be actually fundamentally different in some cases. So I think we have already seen some of those cases in the previous classes, and that's one thing about Python, which provides some more flexibility, but in the same time, it kind of makes it not a low-level language where you have all the low-level access for all sorts of memory efficiency and these kind of things. So that will be also something you'll probably see in today's class. But then the only answer I can give to those questions is that this is how Python is written. It's a flexible language. There's a trade-off and these kind of things. So we'll get to that, but let's see what those are and what are the definitions. So my assumption in the class is there are folks in the class who haven't seen object-oriented programming before. So we're gonna start from scratch, and then we're gonna see some syntax, and after each concept, we're gonna build on top of the previous one. Okay. So object-oriented programming. So what it is overall. So I want to think about object-oriented programming as a programming paradigm. So what I mean by that, so far, what we have seen is basically goes under procedural programming paradigm, where the main focus is on writing functions or writing your main code or procedures where data is passed between them within your code, top to bottom, right? So the structure of your code is all those code that you write on a shared data. So everything's on the same file, for example, or if you're reading some module, importing some module, everything is on that main body of code. So it's based, programming based on shared data. And then use cases for that is basically simple to linear tasks for sequential operations. So usually, I mean, back in school, for my research, I remember I was mostly doing procedural programming because, I was basically doing POCs, right? So proof of concepts. And I just had a simple few lines of code or even, tens of or hundreds of lines of code to just get some plots and verify some fact, right? But when the code, the size of the code gets larger and larger, and the kind of applications you're thinking about gets more and more complex, then it's not really efficient and reasonable to actually stick to procedural programming, because then you realize that when your application scales, then you have to go from hundreds of lines of code to thousands or even more than that. But it really, very quickly gets out of control the way you can actually explore your code, hover around, and learn about different parts. Then you realize you definitely need an organization to your code so that everything is modular, reusable, and it also makes your code much easier to read because now you have actually bundled your data in different classes, and each class has its own attributes and methods. And if you want to make any changes to one part of the code, you don't have to go through so many different lines and try to figure things out. You can just go to the right class and make that change, and that change will be reflected throughout your code. So that's why we're going to learn about object-oriented programming. So these days, if you just randomly pick a code from the open source, like what you can see on the GitHub from OpenAI contributions or Meta contributions or any other open source out there, you rarely see a code which is not in object-oriented programming paradigm. Okay, so now this is the standard, and most of the professional code out there in industry is written in that sense. So I'm going to give you a lot more examples throughout the class through visuals, and I just talk about them. And then on the notebook, we're also going to see another example. So we're going to see a lot of example and visuals to understand this better. So how can we compare object-oriented programming to procedural programming? So unlike procedural programming, object-oriented programming is about objects to bundle data and the behavior of those data together. So we're going to write a class where it bundles some attributes and some methods in one place, packed. And then you can create objects from that class, which inherits all those data at once. And you can even add more attributes to that, but you at least know that there is some parent class which all these behavior is coming from. So it's all about classes and objects, unlike procedural programming, which is about functions and lines of code one after the other on the shared data. But now we have classes and objects out of those classes. And then object-oriented programming is usually not for simple and linear tasks, but for more complex and larger applications. Okay. All right. So many vague stuff so far. Now let's get a little bit more into the definitions and see, what are some definitions, how a class is created, and let's see an example of that too. Okay, so what is a class? A class is a blueprint or a template to create objects, right? So you can think about a class as an actual class, or you can think of it as a set or a family, right? And the objects would be the children from that family, or the subclasses or child classes from that original class or the bigger set. So a class contains two very important components. These are the building blocks of a class. They are attributes and methods. Okay, so when you create an object from a class, what it inherits from that class is basically those attributes and those methods. Okay, now what are attributes and methods? An attribute is a variable that we define in the class, and a method is a function of that class. Okay, so if you remember, from time to time, I used to call different functions of built-in functions for lists or tuples or other data structures as a method. So this is why, right? So a function which is defined inside a class for its objects is called a method, and the variables inside that class are called attributes. And the focus here by creating a class is creating a reusable and making your code reusable code and making your code modular. Okay, so the working example throughout the slides for object-oriented programming is a class which I'm going to call car. So it's going to be the class of cars, where it comes with some attributes and some methods. So in our first example, our attributes of this class is going to be the brand of the car, the model of the car, or the color of the car. And we have some methods, for example, start engine, set speed, get fuel. And each of these functions can have a few lines of code which does some setting for us, or they can set up some configuration, or they can simply print some information in the display for the user. So they can get input, return something, exactly the same definitions that we learned from functions. They can all apply here. Okay. All right. Now, before we go further and understand different parts of class and see what each part and each function will do, I'm going to show you a simple syntax of a very simple class that we can write in Python. So let's first look at the column on the left. So usually the class begins like this. So we have the keyword class, and then the name of the class, which by convention, it goes capitalized in the first, the initial, right? So the first letter C is capital, and then the rest of them are small letters. So this is usually how we define a class. So in some sense, it's pretty similar to other code blocks that we have seen. For example, a function, right? But instead of a def, we are using class. And then there are no parentheses after the name of the class, right? So here, at least in this example, we don't see any parentheses, right? Then we have the colon, and we know that by colon, we mean we are starting a code block. And on the next line, we see the indentation, right? But now we are seeing two functions right after that. So we have never seen a code block which had a function inside it. So the rare case was an inner function inside the outer function. But in this case, each of these functions are actually a method of this class. Okay. All right. So so far, so good. So we know how to define functions, but now we are seeing some new stuff, which in some cases could look a little bit weird. For example, we have been using underscores, digits, and letters to define variable and function names. But this way of defining a new function, like double underscores and then init and then double underscore, is something new. So we have never defined a function name in this way. So in class, there are some templates and some special functions which do which have particular behavior, and they have a particular functionality. So we are going to call them double underscore methods or magic methods. So this init function stands for initializer or constructor, which we're going to learn in detail about on the next slide. But these are some special functions which are specific to a class. So each class has a default for these functions, and if we want, we can override them. Okay, so one of them is init. We're going to see more examples towards the end of this section on the slides. So for now, let's just assume that we can have functions with double underscores before and after the name. These are some special functions, but that's okay to name the function this way. You can also name your own function. For example, for this start engine, you can put double underscores before and after the name and nothing happens. Okay. So the next thing is, this is a function which has three parameters as input. So we have these parentheses, and there are three parameters passed. So the first one is called self, is named self. the second one is brand, and the third one model. So I think the last two ones make sense, right? So this is probably the brand of the car, and then the last one is the model of the car. But the first one is the self of the car, which is a little bit weird, right? And then inside the function, you see that self is repeated again a couple times, and there is a dot after that, and then these two names are repeated again, right? So this is kind of a syntax we haven't seen yet. But now we need to get used to this kind of syntax, because this is how object-oriented is designed to make sure that the attributes that you define become the attribute to any object which will be created out of this class. Okay? So when you see a self, then it means that later when you create an object, that object is gonna understand what these attributes are, and the object is gonna own these attributes for that particular object. So if you create another object, then it comes with its own brand and model, right? So you're creating this class of cars not to just create one object of car, for example, with a brand, I don't know, Nissan and model, some model, right, Altima, or and some color. So you're creating this class to create multiple cars out of it. Otherwise, you wouldn't need to do that. And you would go with procedural programming, right? So you want to make your code reusable and modular, so that if you want to create 100 objects, then you can simply create objects from this class and not write everything that you see here, which is a very simple example, over and over again. Okay? So this is how you assign attributes to the object of this class. So when you create an object from this class, as we will see on the right column a bit later, you pass on the brand and the model, and this self is just an indicator or kind of an identifier that this method is an instance method. So I would use instance interchangeably for object. So when I say instance of the class, I also mean an object of the class. So every instance or every object needs to know that this method is basically something that belongs to that instance and object as well. So that's why we see self. Okay. And then self.brand means that that particular object later has this attribute named brand, which is initiated to be this particular brand that we pass on when we create that object. And same thing for model. Okay. So for that particular object, if you want to actually also assign an empty list, you can do that here. You don't have to pass on these values. You can also create a new attribute for that object, which is an empty list or an empty dictionary. Okay. So I think I'm just going a little bit too fast, because for everything that I'm saying, we have examples, and we're going to see multiple use cases on different examples here and on the notebook. So let me continue. So the next function, you can see that we have a def, the keyword for function, the function name, and we only have the self keyword here. It's not a keyword, actually. We have self and then nothing after that, right? So this means that this function gets no input, and it simply prints this statement on the display. But if you look at it, this statement is an f string and includes both of those attributes that we define here, which means that this instance method shares all the instance attributes that we define here inside the class. So it has access to all those attributes. Okay. So on the right side, the first line, you're creating an object from this class. So this is the name of the class. And here are those two attributes values that we need to initialize right here. So our initializer will dictate that what attributes we need to pass on when we're going to create an object from this class. So we have these two values which go with the same order. The Toyota goes to brand, the Corolla goes to model. So we are creating this object from the class of car, and we are assigning that to our object, which we name my car. Okay. So quickly on the side, whenever you create a list or you create a tuple or a dictionary or a set or a string, they are all actually instances of those classes in Python. If you remember, when we tried to get the type of a list, it would say class list. So that means that whenever you create a class, you're basically creating an instance from the class named list in Python. This is what we're doing here, but we're customizing our own class. Okay. All right, so now that we have this object, we can, it gets all these methods and attributes from this definition. For example, if you write the name of the object and replace self with that, dot engine, and engine doesn't get any inputs. This self is just that instance identifier. If you call that function, it will print this thing in the output. So you see that Toyota and Corolla are now replaced for self.brand and self.model. Okay. And then on the next few lines, we have mycar.brand. If you write it on your notebook, you'll see that you'll get an output Toyota, which is the brand of your car, and then mycar.model, which gives you the model. Okay. All right. So now let's dive deeper into what the init function is and what it does. So the init function is the initializer of the class, but it has a special name. It's called constructor. And if you remember, we had the constructor when we wanted to initiate different data types. We would say you can use a set constructor or a dictionary constructor. But now we know what it means. So it's basically the function in a class which initializes the attributes of that class. So it's a special method in a class to initialize attributes. It's called upon any time an instance of the class is created. So each time you create a class, or sorry, if you create an instance from the class, this function is called, and these values will be initiated. Okay. So this constructor is optional. If you don't override it, then a default init function is used with no arguments. Okay, so basically, it always is executed, but if there are no, there are no attributes here, then there will be no attributes passed to the instance, which is very rare. Usually, that doesn't happen, but that is feasible. So in this example, you see that for the same class named car, we have this constructor. We have the make and model as before, but you can also have other parameters. So here I have year, which has a default value of none, and I have color, which has a default value of unknown, right? And remember that the parameters with default values go last. So on the first two lines, we have self.make, and we set make to assign to that attribute. And same thing for model. These two are required because there are no default values. So whenever we create an object from the class, we have to initialize these values. Okay, but then for year and color, because we have default values, they're optional. If you don't assign these values to these attributes, then they will get these default values, right? And you can also have an empty list assigned to another attribute. So I'm going to define a new attribute called self.features, and I'm going to assign an empty list to that attribute. Okay. So one note here, this self, as I mentioned, is not a keyword. It's just an identifier to show that this is an instance method in the class. You can use any other name. It doesn't have to be self. It could be any name that you pick. But then you need to make sure that inside this method, whenever you want to define an attribute, you have to use the same name instead of self. All right. So for the rest of this section, in the next few slides, we're going to see different types of attributes and methods. So we learned about attributes and we learned about methods in the class. Now, we have different types of attributes and different types of methods. And you're going to see some of them in today's class. But we have more on this list, which we won't get the chance to go over, but I actually provide a link at the end for those of you who are interested. Okay, so the first type is instance methods and instance attributes. So these methods and attributes are specific to each instance or each object of a class, right? So they belong to the instances of the class. And every object of the class has its own copy of the instance method or instance attribute. Okay, so when you create a new object, it has its own copy, but then the next object has its own local copy of the method and attribute. Okay. So for example, one object can change their own attribute, but this change will not be reflected for the other object. So each of them have their own local copy of the methods and attributes that they get from that class. So to define them, you need to use this self keyword, as we have seen, to show that they belong to this object. And here's how the syntax will look like. You have self dot the attribute or method name, if you want to call them, right? And then after the method name, you have to put parentheses. And if you want to define a method, it's def, as we had for the function keyword, then the name of the method, and then inside parentheses, we have self and other parameters if you have any as the input for this function. So going back to our example, class car. So keyword class, and then name of the class car, already seen that. So here's our constructor. It's an instance method which gets brand and model as input and assigns them to these attributes. So one quick note here is you see that the name of the attribute and the name of the parameters we pass to this function, we are using the same words, but they don't have to be, right? So these brand and model on the right, they are the parameters which are passed to this class. And then these brand and model on the left, which come after self dot, they are the attributes of this class and can have a different name. You don't have to set the exact same name. But usually by convention, we use the same name, which makes the code easier to understand that what attribute is getting what value. So we have two other instance methods. So these are all called instance attributes, right? So these are the attributes which belong to the object of the class. And now we also have these two instance methods. First one is start engine, which is just, both of them are just a report on the display. The first one reports the engine of this brand, and this model is now running. The next one, display info, just says the car with this brand and this model is just kind of information about this vehicle. So if we create an object from this class with the input Honda and Civic, so Honda for brand and Civic for the model, right? So as you can see in the constructor, we need these parameters to be passed when you create a class. Then if you call these instance methods, you'll get these outputs from the print statements that you see on these two lines. Okay, so the first one replaces Honda and Civic for these two attributes, and the third one is just that informational message saying car is Honda Civic from this line. Okay. All right, so this was the first type of methods and attributes, instance methods and instance attributes, which are specific to each instance. But we also have methods and attributes which are specific to the class, right? We call them class methods and class attributes. Now, the difference here is that these methods and attributes, they belong to the class itself rather than to any specific object. So think of a variable as some information about the class itself, not necessarily an information for each of the instances or objects you create from this class. Okay, so in the case of the car class, think of the number of wheels as some feature or some property of the class of car in general, but not particularly for a given object, which can have different attributes from a different object. Okay. So these are the methods and attributes that belong to the class rather than any specific object, but they're also shared across all instances of the class as well. So it is a property of the class, but all the instances of the class would also have access to those information as well, right? So when you create an object from this class, for example, a Honda Civic from this car class, it would also have information about the number of wheels, which is 4. Okay. So how to define them? So they're defined directly within class and outside of any methods. And if it's a method, you have to put this at class method sign, which is called a decorator, before the class name. Okay. So let's take a look at this example to understand it better. So here is our class, but now there is no constructor. You don't see the init function because a class attribute is written directly within the class outside of any function, right? So we just put it right after the name of the class. So this is called a class attribute or a static attribute. So static attribute, we're going to see on the next slide, but we call this both because it has both functionality. And then here we have two class methods. As you can see, we have a decorator here. So whenever you see this @ sign and some keyword after that, it's basically a decorator, which decorates the next function in some specific way. So in this case, we want to make this one a class method. This is the key difference between a class method and an instance method. There are no decorators for an instance method, but here we have this class method decorator. And then inside, when you define the function inside these parentheses, you see that we are writing CLS for class, and then we use that name CLS.wheels to return this value. So again, this is an identifier which shows that we have a class method, but the naming is optional. So it's CLS is not basically a mandatory syntax. So you can use any name for CLS. And this function, what it does is it returns this number of wheels, which is a class attribute. So if you want to get wheels, you just call this function, and then it will return the number of wheels for you. Okay. So the other class method set wheels, you can actually get a number and set the number of wheels in this class. So you get this number, and cls.wheels will change this the class attribute to this number. So here, for example, we are going to print get wheels, and note that when I want to call this function, now I'm using the name of the class. You can also use the name of some instance, but even without defining an instance, you can get access to these methods by writing the name of the class dot the function, right? And here I will get the output 4 because originally the number of wheels in this class is 4. And then you can use set wheels to set a new value for the number of wheels, which is just imaginary here. And then get the number of wheels. It will give you 6 this time. Okay. So I have a couple more slides, and then before going to the notebook, I want to make sure that I see there are questions in the Q&A. I will make sure that those are addressed before I move on to the notebook. So another type of attributes and methods is called static methods and attributes, right? So we had instance methods or attributes, class methods or attributes. So now we're going to learn about static methods and attributes. And they're defined as utility functions, right? So sometimes there are functions which are kind of more generic, and they can be also defined outside of the class. There's no harm, right? The only reason that we bring them inside the class is that we want to make the class self-contained, so that all the functions and everything related to this class goes under the umbrella of this particular class, right? So that's why we also have these static methods, which basically are utility functions placed inside the class to make our life easier. Okay. So they're a little bit different. They don't access or modify the class or instance state. So if you look at the way they're defined, there is no self or CLS because they're neither instance nor class functions. When you want to define them to make sure they're distinct from the previous methods, you need to put this different decorator at static method on top of each function. And then they do not require self or CLS. And if you want to access these functions or variables, you need to write the name of the class and then the attribute or the method name. Okay. So note that the way you define a static variable is similar to a class variable. That's why we can call them both class or static variable. There's no difference. Okay. So again, the main difference here when you define a method, a static method, is you put a decorator which says static method, and then there is no self or CLS needed for these functions. So here, again, I write the name of the class. .wheels will give me this value of this static attribute. And then the name of the class .car info without any input will just simply print this line. And in this line, you can also get access to that static variable car.wheels. And then if I want to call this describe car, name of the class, then the name of the function, and there's an input here, Toyota will go right here. And then you can also access that static variable as well. Okay. All right, so we learned about instance, we learned about class and static methods and attributes. The last thing we're going to learn about in this class would be magic methods or dunder methods. So dunder comes from double underscore. Um, so it's basically gets the D from double and then under. So double underscore methods or magic methods are those methods which define how objects of a class behave with built-in operations and methods. Okay, so there are some built-in functions for each class, and we're going to customize them. Otherwise, they just come with some default behavior and pretty much useless if you don't define or customize them. They start and end with double underscores, and here are some examples. The init function we've already seen. We have the add function, string for representation, REPR again for representation. We have two different ways. So string is basically focuses on the string side of printing something. You have the length to get the length of an object from the class if it is meaningful. So for all those data structures like list, string, tuple, dictionary, set. So you remember that the len function was the same the way we defined it. So here, this is where it comes from. Okay, so if you want to change that definition, you have to customize it here. And get item, for example, to get access to different indexes, if that's also meaningful. So we're going to see examples of all of these. If you are more interested in magic methods, see this link below. So some examples you can see on the right. So we're already familiar with the constructor. For add, you can actually define it to actually print something, right? So you can actually print self.self-make and self-model. And you can also get another object. So you can put self and other. Usually that's the case if you want to get, because this add function is applied on two objects of this class. Then the first object comes with self, the second one comes with other. So you have self make, self model, the and sign, and other make, other model. Okay, so if you have two objects from this class and you add them up, you'll see that you get this thing in the output: the make and model of the first one and the make and model of the second one. And then representation, if you want to print the object and get some meaningful information in the display, yeah, you can actually define that under the representation method. Okay, so let's see. So let's say we have these two objects from the car class, right? Now, if I add them up, so when you customize this function add, then it basically, if you want to use it, you can use this plus sign, right? So that's why plus means different things for different data types, right? So for integers, the plus sign is arithmetic addition, but for strings and lists, it's concatenation, right? You can actually customize that to something new. In this case, we're just printing this. Car1 and car2 is going to give us this output. So Toyota Camry and this and sign, and then Honda Civic, which is the second part. Okay. But note that the add magic method needs two objects, right? And then the representation give us some meaningful representation when we print that object. So that's what we define here. Okay. All right. So before we go to the code, I mean, some questions, and then we go to the code. Here's all-in-one view. So I've actually written the class on the left, and so here's the class with all the functionalities that we learned, and then on the right, I'm creating an instance from that class. Okay. So we have class variables, instance methods, class and static methods, and magic methods. And on the right, we are defining an object, and we are calling some of these functions here. So I give you a few seconds to look at the screen, and then I go over that. In the meantime, I'm taking a look at the questions on the Q&A. So take a look at the screen and see if these things make sense. And then I go over that, and then we see more examples on the notebook. So I shared the link to the slides again in case you haven't got it. So you can see that on the chat. So going over the questions in the Q&A, a couple of them, let me get to them right now. So all the functions defined in a class will by default have access to init. The answer is yes, as long as there are instance methods, they do have access to all the instance attributes which are defined in the constructor. The next question is the self stand in just required to be the first parameter in a constructor? The answer is yes. It's very important that the self that you're going to use as the object representative always as the first parameter as to any instance method. So self always has to be first. Can we skip having self or other word and just list parameters like function? The answer is yes. Then you have a static method, and then you need to put the the static method decorator on top of that. Yeah, so you can skip that, but then you need to make sure that it follows the right rule of writing the method. So let me see. There is a question that there are no access modifiers in Python for class. So if you meaning if by that question you mean defining a setter and getter to modify internal data, then yes, you can actually do that. We don't see it today, but yeah, there are ways to modify the values within functions. If you define those methods, there are ways to do that with setters and getters. So there's a question that we do not have to declare or define the attributes in the class definition. So I think we already discussed that, right? So if there are instance or class or static methods, then we need to define them. But then it depends, right? So if there are instance methods, you put them on the constructor. If not, you'll bring it outside. I'm not sure if I'm addressing this question, but I think we already discussed that, and we're going to see more examples too. So there's another question: when is the right time to use instance versus class attributes? So instance attributes are the ones which belong to each object or an instance of the class, and the class attributes are actually class properties. You can think of it as a property which is mainly about the class itself. For example, here we have number of wheels, which is a property of cars, but we also have make and model, which is a property of an instance of the class. Yeah, and then that would make some difference in the type of access that we have to these attributes, but that's the overall idea. If I don't use the decorator class method, getWheels won't be treated as a method under car class. That's right. So if you want to make sure that this, for example, this get number of wheels is a class method, you need to actually provide this decorator class method on top of it. If you don't do that, then what happens here is that it becomes an instance method, right? By definition, like this one, and this CLS would become this self, right? So it doesn't matter what name you choose, but this CLS would be the representation of an instance for this class, for this method. I think I heard you mention that instances of a class could also have access to a class method. Could you show an example of how that is done? Yes, we're going to see that on the notebook. Why do we need both static and class methods in Python? Because their definition are different. So class methods are basically methods for the class, but static methods are utility functions. They could be outside of the class too, but we bring it in to make this self-contained, right? So and then the way we define them are different, right? So there's no CLS for static, and then decorator are also different. So I think this will become more clear when we see an example on the notebook. If we have class method, why we also have instance methods or static methods? Can all these different methods coexist in the same class? The answer is yes. You're seeing an example on the screen, and we're going to see more example of that too. A follow-up question: when do we use a static method and when do we use class method? I think I just addressed that. So class method is for the class, but static method is utility function. And let's see, a couple more questions, trying to go over them very quickly, but let's see, what's the time? Okay, so actually let me move on, and then I get to the questions after the examples. So on this class, you see that we have all those instance, class, and static attributes in one place, and plus a magic method. So we have this class variable, number of wheels. Here's the constructor, which we had. We have two attributes that we define here. And then the display info to just give us some information on the display. And then we have the class method, get number of wheels. And then we have a static method here, which gets no input and just returns true. It's just a very simple, random static method here. We're going to see more meaningful ones on the notebook. And then this magic method, or the double underscore method, which gives us some representation of this car. So on the right side, we are going to create an object from this class with this make and model, Tesla Model S. And then when we call the display info, we get this output, right? So from display info, we get this output. Get the number of wheels, give us 4, because this is the number of wheels that is returned in this class. And then we're going to see if this is a vehicle or not. This method, static method, always returns true. Note that for these two, we are calling this function and this function with the class name. And for this one, we're using the instance name. We could also use the instance name here as well. And then last one is the magic method. So if you just print car, simply the object that you created, you will see this representation right here. If you don't define this representation, you'll get some random encoding for the memory location and those kind of things that you have seen before. You'll see that. So that will be meaningless. Okay. All right. So let's now go to the notebook. So I'm going to go over some examples here too, and then we're going to have a class activity for you to try this out. And while you're working on class activity, I go over the rest of the questions on Q&A. All right. So I'm going to define a new class here. So I'm going to call the class student. So I have a constructor and I have this instance method here. So in my constructor, I'm getting the name and I'm assigning the name to this attribute called name as well. And whenever I define this, get an object from this class, I'm going to print something in the output saying that a new student is added with this name to this class. And for each student, I'm going to have a list of grades. So other than the name, which is assigned from this given value, I'm going to print something to show that this student is added. And then I'm going to also create a list of grades for that student, right? Now, on the second method, I'm going to add grades for this student. So this is a method, this is an instance method, which gets a course name and a grade, and then creates this tuple and adds that tuple or appends that to self.grades, right? So self.grades is defined right here. And then we're going to print that this grade is added for this course. Okay, so this is my base basically class, which on the next few examples I'm gonna keep these things and I'm gonna build on top of that to add all those different methods and different attributes that we learned. Okay, so now for now let's just try this out. So I create this class and then I'm gonna create an object from this class. So when I run this cell, you'll see that I get this message, new student added with the name John, which comes from right here. Okay, so now because when you create an object, this constructor is always gets executed. So you'll assign this attribute, and then you print this message, and then you also get this list of grades for that student. For example, if I write student1.grades, you'll see that we have an empty list, right? And if I print the student without defining any representation, it gives me this thing. So it's saying that we have an object from the student class at this location in the memory, right? Which is not that meaningful. And then the type of the student one is class of student, right? So we're going to make this more meaningful when we add a representation magic method to it. So moving forward, student1.name is going to give us the name we assigned. And then I want to add grades for this student. So student1.addGrade, which is this function right here. So let's say for the course algebra and the score 87, I'm going to add this grade to that empty list. So right after that, I get this print on the display, grade 87 added for course algebra, right? Okay, now if I look at that student1.grades list, now it's not an empty list anymore. It has this tuple added, appended to it. And if I add another grade for physics and 65 as score, you see that the grades is now, we have 2 grades, right? We appended one more to the list of grades. Now I'm going to create another student. Student 2 is named Mary. Here's its name. And then student2.grades is going to be empty because so far there has been no grades added yet. But I'm going to add these 2 grades. So you see that we have these 2 grades added, and then here's the list of grades for that student. So if you want to change the name of this student, you can do that. So the name will be changed. But you can also restrict that inside your class. So you can encapsulate your class. We're going to learn about it on the second part of the class. Okay, so this was our base example. Now we're going to see some more examples here. So let's say we had an instance class. Now we're also going to add, we had an instance method. Now we're going to add a class method to this one and a class attribute. So this is our same class as before. So this is the constructor and this is the add grade method that we had. Now we have this additional class attribute named number of students, which begins from 0. So whenever you add a student to this class, in this constructor, this number of students is incremented by 1. Okay, so this is a class property, not an instance property, right? So when you add a new student for this class, you're adding one more object and you're getting that object incremented. So note that we use the name of the class here. And then here we are defining a class method, right? So the class method has this decorator, which you see that has a different color coding as well. So it's a class count, and it counts the number of students in the class, and will return that as an output, right? So now, what is the class count in the beginning? It's 0, right? So I'm calling this function, and it's going to get that number, which is 0 originally. And I'm going to create one new student, John, and then now I take a look at the class count, which is 1. And I create another student, and then I get the class count, which is 2, right? Now, if I look at the class counts from these two instances, so the first one and second one, they have a copy of that class count. So when you add a new student in the class, that number is also shared with the different instances of that class. So if I go ahead and let's say I create another student, let's say I'm gonna name them Bob, then you can see that we have now 3 students in the class. And if I this one again, it says this object has also a shared knowledge of that class count as well. Okay. All right. Okay, so this was the class method and class attributes. Now let's take a look at an example for static methods. So we have everything the same. So we have the constructor, the class attribute, and here we have the class count. And we have the add grade as well, but with a difference here that now I don't want any numeric grades. I want to have letter grades, right? So instead of having, for example, 95, I want to have the score A. So that's what I'm going to do here on this function. So here we have a static method. It's called grade mapper, which gets the score, and it will return the letter grade corresponding to that score. So if that score is between 85 and 100, it returns A. If it's lower, it returns B, C, D, and F for fail. Okay. So the way we use this grade mapper is here, when we are going to add grade, we map the numeric grade to a letter grade, and then we basically append that to self.grades, which was an empty list originally. Okay. All right, so let's see how it works. So I'm gonna create an object from this class. Now, when I add this grade, you see that now the letter A is added instead of 87, right? And when I add the second one, I have a C added here, not 65. Okay. So now you can see the difference here. So we need this static method because this is a utility function, right? So it's not a property, not necessarily a class or an instance property. Is some helper function, which kind of facilitates some computation, but we bring it under this class to make sure everything is in one place. Okay, but you could actually bring this outside of the class and use that function inside the class. That's also fine. All right. So the next example is magic methods. So we already had a magic method, which was the init function. But now, besides everything we had so far, we also have these 4 magic methods. So the first one is representation, which gives us this representation when we call or actually print the object. We can define the length of this method, the length of this class. So we can have the number of students that we defined earlier to be returned as the length. We have this add magic method, which gets 2 objects from the class, and I want to print first student and the second student and an and in between. And we also have this get item object, which gets an index. And it checks to see if the index makes sense and it's not out of range, so that it can actually give us the grade corresponding to that index. Okay. All right, so let's see the example here. So we create an object from this class, and we're going to name him John again, adding 2 grades for algebra and physics. Now, let's see how those magic methods work. If I print the student, or if I use the str function for a string, it will print that representation for us. So you can see that if you define this representation, it already goes by default for string as well, right? It just returns a string here. And the other thing is you can actually customize a string separately. So you can have a string magic method here as well. But if you don't, by default, it will get the value you put for representation. So all of these are the same. So you can print the object or the string of that object or representation of that object. They all return the same thing. And then the length of the student is 1 because we had only 1 student so far. And 0, 1, 2 are going to give us the way we define this indexing was to get the grades. So for example, at index 0, we have this grade, right, which was our first grade. And then at 1, we had the second grade. And at 2, we will get index out of range because we were checking the indexing right here, right? Okay, so let's create another object. So let's name the student Mary. Now the length if you check the length of any instance of this class, now it's 2, right? So if I also show you, the length of student 1 is now 2, right? So the length of, for each object, the length is now giving us an updated value. And then if you add them up, student 1 and student 2, you'll get this representation, which we define right here. Okay, so we customized our add function to give us student's name and second student name. Okay. All right, so now it's time for our class activity. I'm gonna go back to the slides. So the class activity is a little bit different from our previous class activities. I'm gonna give you more time on this one. And I want you to design a bank account class. So this is a class which simulates a simple bank account, and I want you to implement these things. So it should begin with a constructor to initialize the bank account. And then we have these attributes, right? So I'm not going to go over them. Then we have these instance methods. So we have 3 instance methods which we're going to define for depositing, withdrawal, and to get the balance, the current balance. We have a class attribute for the bank name. We have a class method to set the bank name. We have an static method to calculate the interest, given balance and rate. And we have these 3 magic methods that we're going to define. Okay. So I'm going to fix it on this screen, but then I'm going to go back to this screen. I'm going to write the code on this block, and then we're going to test our code. Okay. So we're going to create 2 bank accounts and then try out all those methods and instance and class methods and other ones. Okay. So while you're thinking about this, I'm going over the Q&A and typing the answers for each one. And in the meantime, if you have any other questions, please put them in the Q&A. After the class activity, I will also let you, if you want to discuss further, I'll let you raise your hand and we can discuss further. Right. Let's go over this one by one. Okay, so first I'm going to create this constructor. So it says, let's see. So it wants us to create a constructor to initialize 3 instance attributes: balance, owner, and account number. Okay, I also, for each of these, I will also add a message at the end to show that we have actually created a new instance. So let's go back here and start writing this class. So I'm gonna define the init function, so the initializer or the constructor, which begins with self, and then we have owner, we have balance, and we have account number. Okay, so we have 3 values, and we pass them on to the attributes of this class. So we have owner, and then we have this attribute balance, and then we have account number. And then I'm going to also, after I create each bank account, I'm going to print that, let's say, account created for this particular owner. Okay, so let's put owner here. All right, so this is my constructor. Hopefully there's no typos. Okay. Okay, so this is the first part. Then we are asked to write 3 instance methods: deposit to add a specified amount, withdraw to deduct a specific amount. We need to check if you have sufficient funds for that, and then to get the balance that returns the current balance in the account. So let's define these 3. So the first one is deposit. So it's an instance method, so it has self and then amount, right? And so what deposit will do, it will get the amount, and then for this balance that we have, it will add it on top of that balance. So we have self.balance, which gets that additional amount, and then I'm gonna print these number of dollars, amount deposited, and then the new balance is so basically we're gonna get so we can either use self.balance, or we can basically use that get balance function that we're gonna write shortly. So get balance. So I'm gonna define get balance here after that. Okay, so let's pass it for now. Okay, so this is our second or first instance method to add this amount to our balance, and then we are gonna get the new balance after the deposit. So before the get balance method, we also had withdraw, right? So withdraw, which is also an instance method, and it gets an amount. Now we need to check if this amount is greater than our balance or not. If the amount is greater than the let's say self get balance, if that's the case, then we don't have enough funds, right? So we are gonna print insufficient funds. Okay. Um, Otherwise, we can just remove that from the balance, right? So we have self that balance, which gets this amount deducted, and we get these number of dollars amount withdrawn, and then the new balance is this thing that we had earlier. Okay. And then get balance will just return the balance, right? So it will return self the balance. We can skip that, but sometimes we don't want to get direct access to these attributes in a class. So we define these kind of functions to make sure that there's no direct access to these things. All right, so far so good. So these are our instance methods. Going back, we have a class attribute and a class method. So the class attribute is bank name, which is a shared class attribute that holds the name of the bank, for example, Python Bank. And then set bank name just gets the name and sets for that bank name. So let's implement that. So for the bank name as a class variable, I'm going to put it right here, bank name. And by default, we're going to go with Python Bank as the question asks. And then I'm going to define a class method. And it's going to be a class method. So here's the decorator. And I'm going to define the name is set bank name, new name, right? And then it's gonna actually get this new name, and then it's gonna swap the original name with that new name. Okay, so here's our class method. So the next one is a static method calculate interest, which gets balance and rate and give us this formula. Computes this formula. So static method goes with decorator static method, and then the name is calculate interest. There's no cell for CLS, it just gets balance and rate, and it will return that formula, balance times rate divided by 100. This is gonna calculate interest for us whenever we call it. Okay. All right, and then the last part is magic methods. So we're going to define these three. So for representation, we wanted to have this look. So bank account owner and account number, the length, and what does add do? So add would allow two bank account instances to be combined, adding their balance together, returning a new bank account with the combined balance and a generated account number. So I'm going to show you a trick to actually generate a random account number just for fun. But let's actually go back here. So first, I'm going to define the representation. representation, and then it's gonna be it's gonna return what the question was asking. So it's gonna be bank account, and then we have owner, which is self.owner, right? So coming from right here, and then the account number comes from here. So it goes bank account owner and account number, which is self dot account number. Okay, so this is the representation. The next one was length. So the length um, is, so we're just going to get the length of the account number. So in this case, we'll make it simple, and it's just going to return the length of the characters of the account number, length of self dot account number. Okay, and then the last one is add self and other, right? So we get two objects, and what we're gonna do is we're gonna get a combined balance, right? So we have a different account name, and then we're gonna combine the balances of these two. So let's say combined balance is self dot balance and plus other dot balance, right? So this is the combined balance. Now I'm gonna generate a code. So let's say random generated code. I want it to be 6 characters of letters and digits. So I'm gonna define a function and generate code, which gets basically nothing, right? So it's just I can just call it from the name of the function, because I'm going to define a static method for that. Okay, so here's my generated code. I'm going to implement it shortly. And then when I have that code, I'm going to return the bank account of, and I'm going to name the bank account the combined account. So that's the name. And it's gonna have the combined balance. And so what's the order? Then account number. So the account number is random generated code. Okay. So this is how I define this add method. Now I need to also define another static method here. Static method. And I'm going to define it what? I'm going to define it generate code, which doesn't get any input. So I'm going to use the random generator functions in Python that we've already learned. So I'm going to import random, and I'm going to import string. So string, we haven't seen that. So this is the first time we see it in class. So I'm going to get characters. I'm going to get a list of all characters for letters and digits, string dot ASCII letters plus string dot digits. So these two are going to give us what we need. So let me show you quickly what these contain. So for this import module, you can actually get access to all letters, as you can see it here, or all uppercase and lowercase letters, and also all digits, right? So I'm going to combine them together. So if I combine them right here, I will get all letters and all digits, right? And now I'm going to get random picks from all these things to get a 6-digit or 6-character code. So I have all the characters, and what I'm going to return is I'm gonna random choice. So random dot choice or choices. If you remember, if you have a list of characters or a string, you can pick the number of choices you want to get from this set of numbers. But then let me show you what this gives us. So this is going to give, sorry, so I need to import random as well. So this is going to give us a list of random characters, right? So if each time I run this, it's giving me a list of these characters. I just need to join them to make a 6-digit account number or 6-character account number. So join. Now this is going to give me a 6-character account number. Okay, so this is my trick to actually create an account number. Okay, so return this thing. I just need to make sure I'm joining it. Okay. All right. So I think we're good now. Let me make sure. So generate code. It's here. Okay, so let's try it out. So I'm gonna run this. So see if there are any issues. So I'm gonna create 2 account numbers. So I have 2 objects here, and the first one, the owner is Alice. There's a 1,000 balance, $1,000 balance, and then this is the account number, some random 126. And then the second one, the owner is Bob, $500. 621 is the account number. Okay, so when I run this, it says account created for Alice, account created for Bob, because we have this reporting right here. Okay, so account 1, I'm going to deposit 200, and then from it, I'm going to withdraw 300, and then I'm going to get the balance. Okay, so it says 200 deposited, the new balance became 1,200, and then after withdrawing 300, because there was sufficient funds, I will get a new balance of 900, and then the current balance is 900. So far, so good, right? I'm going to set a new name for this bank account. So let's call it New Python Bank. Just for fun. And this is our new bank name. And then I'm going to calculate the interest, getting the current balance of account 1 with the rate of 5. The interest would be 45, right? So if you, what was the account 1? So for this 900, if you multiply it by 5, it becomes 4,500. Then divided by 100 will be 45, which is the interest that we calculated here. Okay. And then for representation, so let's do these one by one. So representation, this is how it looks like for both of them. And then if you want to combine, actually length is separate. So the length is 6 because each account has an account number with 6 characters, right? And the combined bank account is the combination of the 2 account created for a combined account. So if you want to look at how it looks like, so it says the owner is now combined account for the account number with this thing, and you can also get the deposit and everything, right? So you can see, for example, what was the name? Get balance, right? Or combined account dot get balance will give us 1,400, which is the balance of combined accounts, because we had a 900 here and 500 here, so it will give us a 1,400 combined. Okay. All right. So that was it for the class activity. Hopefully, it makes more sense that why object-oriented programming is helpful, but especially if you're seeing this for the first time, I'm not expecting you to get super comfortable because it's a new programming paradigm. I want you to take a look at these things after the class as well and go over the recording if you need to. and I'm sure that you'll understand it better. So we are done with the first part of the class, but before going on a break, I was looking at the Q&A. I think most of the questions were addressed. So there's another question that don't we have to check that the account number we generated doesn't exist already? The answer is yes, for sure. This is just a very kind of basic example, and there are lots of things that need to be checked. But yeah, you're right. So we have to keep a list of all the account numbers, and then when you create a new account number, then you need to double check here maybe. So maybe here what you can do, you can set this to um, uh, account account new account number must would be to this one, and then this account number you need to do a check here, right? So you can write a function for check, and then it could check if this account number exists in the history of the account numbers. If that was the case, then you will generate a new one. So you can put this in a while loop. We will generate one after the other and make sure it's not in the account numbers. But I will leave it to you as an exercise. So yeah, that then there are other things that you can do to make this more practical. All right. So any other questions before we go on the break? So the question is the diff if important on the top or inside method. Yeah, let me guess what the question is. The diff is important. Oh, I see. So I think you're asking that what's the difference that we put the import here or outside? So usually the standard way is to put the imports outside here on top of the code. But then it's also okay. You may see that people import what they need inside a function because you don't need that in the other parts of the code. So you make sure that it's only called when you need this function. Sometimes you don't even need to call this function. So you just import it right where you need it. So it is fine, but usually the convention then or standard way of coding is to put all the imports, the libraries that you want to import in the beginning of your code. So question is, are annotations mandatory? Yes. So these are called decorators, and they are mandatory. So that is how you define a class method and a static method. If you don't put it, then it will be interpreted as an instance method in Python. Question is, where did we call the add method? So the add method, when you define it, because it's a special method in the class, it will be called when you use this addition operator. Okay, so that is one of the special methods in the class that when you define it, then you activate or basically overwrite this addition function. Right. Any other questions? All right, so we're going to continue this class activity in the next part when we learn more about the other topics, and we're going to basically build on top of this one for the next example. So I see there's another question. Can we use class method instead of a magic method? Probably you can, but if you can do something with the magic methods, then maybe that's the better choice and a better coding practice. But yeah, you can, I mean, do anything, right? So you can customize any of the methods, or you can create these methods again with all your own use cases and your own applications. But the thing is, these magic methods are there to make life easier, for us not to reinvent the wheel. So I would say if there's something you can do with these methods, then yeah, those are, that's a better coding practice, making everything templatized. So other question is, can you write sequential or procedural and object-oriented programming code in the same Python file? If so, what is the order of execution? The answer is yes. The order is similar to what we learned for scope of variables. A class will be executed whenever it's called. And when we create an object from the class, that's the place that we call it, right? Otherwise, the code will continue to execute the main body of the code. And whenever we create an object from that class, now we jump to the class, and by default, the constructor will be called. And then all the other methods will only be called if they're actually called as instance or class method calls from that object in the code. Okay. All right. So let's now go for the break for the class, and then after that, we'll be back and continue with the rest of the agenda. So we have another part for the object-oriented programming, and then we're going to continue with some other tools in Python, custom sorting and exception handling. Okay. All right. So let's go for the break. I'll see you in 10 minutes. Right. We'll come back. Okay, so we're going to continue with the remainder concepts of object-oriented programming, and then we're going to see some custom sorting functions in Python, and also how we can do exception handling. All right, so now we have seen the basics of how to define a new class and what are different types of methods and attributes. Now we are going to see some concepts in object-oriented programming, which are really important and kind of foundational in each time you define a class, and can basically facilitate writing further classes when you have already one in place. So the ones that we're going to cover in this class are inheritance, encapsulation, and polymorphism. But these are just three of multitude of these kind of concepts for classes. These are three very important ones, which kind of gives you the basics that you need for object-oriented programming. So what is inheritance? So inheritance, so the main purpose here is to reuse code across different classes. It allows one class to inherit properties from another class. The class that inherits those properties, we call them child or subclass. And they inherit the properties from a parent class or a superclass. Okay. So why do we need inheritance? Because it promotes code reusability, and it also forms a hierarchical structure, which is really helpful if you want to create new classes, but those classes have a lot properties in common with some previously defined classes. So getting back to our working example of car class. So let's say this was our original parent class. Now I want to create a new class named electric car, and on top of whatever methods and attributes provided to us from the parent class, we also want to add new methods and attributes. For example, one method could be charge battery method, or the other method could be, for example, the cruise control method or autopilot method, things like that. Now, looking at the code, so if this was our original class with one simple constructor here, now we have a new class named electric car. And now we are using parentheses for defining a class as well. And inside the parentheses, we are placing the name of the parent class. And now the parent class has its own constructor and also a new method. So the constructor starts with a super method, right? So super means I want to inherit whatever defined in the super class, which are these lines. And it says super init and then brand and method. And then on top of that, the next line says this subclass or the child class also has its own attribute on top of those two, which is the battery capacity. Okay, so this super method is not just used for constructor. It's also usable for all other methods. Whenever you put super, then it goes with the exact same definition or implementation of the same method in the super class. Okay. So this one is also another method on top of whatever method comes with the parent class. In this case, it's called charge battery, which reports this thing in the display. And then the way to create an object and to use these things is pretty similar, because now we have a new class, right? So there's no difference between this one and another class. So I'm creating an object here on the first line, where I have the brand and the model and the battery capacity. And then when you call the charge battery method, it will print this this statement in the display. Okay. So a real example of this would be, let's say you find an open source code from OpenAI, and then you try to write your own code on top of whatever they provide. So you inherit from those classes that they define, and then you customize your own subclass based on a lot of things which is implemented already by OpenAI, and you don't have to implement it again. So you write your own class, which is inheriting a lot of things from OpenAI superclass. So the next concept is encapsulation, which is for protecting the data. So we know that one of the main reasons that we're learning object-oriented programming is that because it bundles the data under a class, all the attributes and methods, they're all bundled in a single class. But so far, we have no restriction on accessing any of those attributes and methods. And anyone who creates an object from that class can get access to those values, and they can also change those values and functionalities. Okay. Now we're going to learn how we can actually restrict access to some of those attributes and methods, right? So encapsulation is basically the concept of restricting access to certain parts of an object, and this keeps data inside an object safe from unintended changes. Okay. So we define them, for restrictions, the only difference comes with the naming of those variables and functions, which is just by using underscores. We have three types: public, protected, and private. So public attributes or methods are the ones we have already seen, no change in the naming, and they're accessible from anywhere, both inside and outside of the class. And the syntax is just self.name, right? The name of the attribute, the name of the method, with no difference. So we also have protected attributes and methods, which is also accessible anywhere, but should be treated as non-public, right? So you can still access the protected attributes and protected methods, but it's not recommended. And whenever you see an underscore if the name of the attribute initiated with an underscore, then that is kind of a sign that this is a protected variable. It's non-public, and it's highly recommended not to make any changes. If you want to make any change to such methods or attributes, you have to do it with caution, right? Because it's not intended for change. But if you want to strictly basically strict the access, right? So and make sure that no one can actually access this outside of the class, then you need to use double underscores before the name. Okay, so this makes those attributes a private attribute or a private method, so that they will not be accessible outside of the class. Okay, so once again, public is accessible from anywhere, protected is also accessible from anywhere, but it's kind of a sign to show that this is not public, and it's not recommended for access or change. But then private makes it more restricted, and it shows you an error if you try to access them outside of the class. So here are the code for encapsulation. So on the left side, wherever you see an attribute with an underscore, it's now a protected attribute. And whenever you see a method with an underscore in the beginning, it's a protected method. Okay, but you can access them outside of the class and there will be no errors. It's just recommended not to do that. But on the right side, wherever you see double underscores before the name, it means that this is a private attribute. And for a method, when you see this double underscore, it means it's a private method. And for those methods, there will be an error raised saying that this class has no such attribute or no such function if you try to access them outside of the class. So the last topic for classes that we're going to learn is polymorphism. And polymorphism is one tool we can use for interchangeable objects in between classes. So polymorphism allows different classes to share the same interface and be treated as objects of a common superclass. So basically, you can have some template or the same same method name for different inherited classes, and they can actually you can consider that as an interface where each subclass can define for their own use case, right? So you define methods in the parent class and you override them in the child class. So this is the idea of polymorphism. So this enables code reusability, flexibility, and improved maintainability. So this is how we can use it. So let's say we have a parent class named car again, which has a method named start engine, and this start engine is probably defined for some random car, some originally defined for some historic use case, and then you define a subclass named electric car. Down the road, few years later. And then the functionality is now different. So you can override that method with a new functionality, or if it's reporting something with a different report, because the capabilities and functionalities of electric cars are totally different. So you can override that method. So this is called polymorphism, where you have some method defined in a superclass, but any other class inherited from that can have their own method with the same name, but with the different use case. So in a real world example, I can think of you inherit again some open source class, let's say some some of the open source code from Meta. You get one of those classes for one of their machine learning algorithms, and then usually these machine learning algorithms they come with so many different methods, and each of one of those methods is a component in handling part of that algorithm. And then there is a run function or run method where basically is to run the algorithm. So that's the um, basically the interface of the whole algorithm where you initiate everything. And then if you want to make changes to the algorithm, you go to the other methods. But this run method can be defined in different ways. And if you basically clone that repository, you can actually customize the run method based on your own use case. So this is one example. Then you can, here we are defining a function outside of all these classes. So it's called start any car, and this function as an input gets an object, right? So functions can get anything as input, right? So it can get any data type. They can also get an object. And then we call the start engine function for that object inside the function. And then here in the main body of our code, we are creating an object from the car class, and we are creating another object from the electric car class. And then we call this function on each of those two objects. And for each of them, we get the corresponding message in the display. Okay, so this is called polymorphism. Okay, so let's get back to our notebook and see how these things can be implemented on top of the example that we had already. So this is our previous example. So we had this student class, we had some class and instance attributes, and then we had this instant method to add grades and for counting the number of students in the class. And we had a static method, right? So this is our previous example in today's class. But now I'm going to define a new class, which I'm going to call it new grad, which is inheriting from the student class. Okay, so this is an example of inheritance. And then for the constructor, I'm going to get the name of the student as well as the school, which is a new attribute, which I'm going to define here. And then the other attributes would also, for example, the self-grade would also be part of the list of attributes here, but there is no need for initialization because it goes with an empty list. So I don't need to define that here. Then I'm going to define this is passed, which we had earlier. So if you remember, we had an is passed defined. But now I'm going to define it here for my subclass in a different way. Actually, sorry, we didn't have is passed. We just had I think we had just a static method. Forget about it. Yeah, so we are going to define this new instance method, which checks the grades one by one, goes into the list of grades in this for loop. And then if any grade is greater than C, then it's going to say that the student has failed because this course's grade is not good. It will return false. And then if all of those are above C, it will print that the student has passed all tests, and it will return true. Okay, so basically what this subclass is doing is inheriting all these methods and attributes from our original class or parent class, and it's also adding this new method on top of that. Okay, so I'm going to create a new grad object named John and attending school UCLA, and then I'm going to add these two grades for that student, and then I'm going to check if the student is passed. Okay, So the new student is added, grade B added for course linear algebra, grade C added for the course optimal control. But John from UCLA has failed the course optimal control with this grade. So it will return false for passing. But then the next student has got A for statistics and B for computer vision, and they have passed all tests. So the isPass function will return true. Okay. So a quick note about multiple inheritance. So let's say we have 3 different classes. So class A has method A, which prints something about A, and there's a shared method which prints shared method A, right? And class B has method B, which prints something about class B, and then a shared method which prints shared method B, right? So these are 2 independent classes, right? But then a third class, class C, is inheriting from both A and B, right? So it's inheriting all these methods and all these methods from class A and B. It has its own method C, but there's also a shared method customized here for C specifically. So we have shared method in all of them. Now the question is, if C is inheriting from A and B, what will be the value of shared method when it's printed out for an object from class C, right? And what happens if this was not customized for C, right? So here I'm creating an object from class C, and then this object has now access to all these methods, right? Because it's inheriting. It has method A, method B, method C, and also a shared method. But let's see what we get for each. So we have object A, object method A, object method B, and then method C. We call all these functions. And then we also call the shared function, right? So for the first 3 methods, not surprisingly, we get method A, method B, method C, because this is how we only have one of each, and then this is how they are inherited. But for the third one, the shared method, we get shared method C, because class C is inheriting. It's customizing that for its own, right? Now, what happens if I comment this out? If I comment this out, now what will be which shared method is gonna be inherited by class C? Okay. So if I run this cell again, you see that the share method down here says shared method A. So when we have these two, a class inheriting from 2 other parent classes, it goes with the same order of inheritance. So class A has the higher priority, and then is class B. Okay, so this shared method is called from class A. But if there was no class A, so if I remove shared method from class A, then it would go with shared method B. Okay. Or if I change the order here to B and A, then it would again go with B and then with A. Okay. So this is basically called method resolution order, MRO. So MRO is another magic method which you can use to get this ordering. So it says the order goes with class C first. For class C, it goes with C first, and then A, and then B. Okay. All right. Let's go to the next example, encapsulation. So there's not much difference with the syntax here, but I'm just using underscores to make these attributes protected or private. So for example, here I'm making number of students protected, and then here I'm making the name of the student protected, but also the number of students in the class. But for grades, I'm making it private so that there won't be any external access to this attribute. I'm also making this grade mapper restricted from outsider use. And yeah, so those are some changes I make to this one. Now I'm going to create a new student, John. I'm trying to get their name. That's fine because it's protected attribute. Also, getting the number of students in the class, you can get that because it's a protected attribute. Same thing with this method class count. But when I try to get the grades of the student, I'll get this attribute error saying that this student class object has no attribute grades. Basically, I cannot get access to these private properties of the class. And if I try to use the grade mapper outside of the class, then I will get this error that there's no attribute called grade mapper in the class. Okay. All right. And the last example for polymorphism. So let's say I have this class of students again. Everything is the same up to this point. But now I also have this function named isPassed, right? So it's an instance method isPassed. And I'm not putting anything for it. I'm passing it for now, no implementation. I'm just putting it as a kind of a blueprint for now, so that I know we can implement that later. Now, in a subclass named new student, which is inheriting from the student class, other than the constructor, I also override this isPassed function and basically make it a specialized function for a new student. Okay? So this is an example of polymorphism where you can have a function in your superclass and then all the subclasses basically custom define that method. So here I'm gonna create a new student, and then with adding these grades, then I'm gonna call the isPassed. Similar to our previous example, but now just wanted to show you that this is also an application of polymorphism. Okay. All right. So let's go over the class activity, which is continuing the bank account example. And then while you are working on it, I will go over the questions on the Q&A. So the extension of the bank account class is going to ask you for 3 main tasks. So for inheritance, it's asking to create 2 subclasses, savings account and checking account, that inherit from bank account. And for each, you're asked to add a new attribute. For the saving account, add the interest rate attribute, and then for the checking account, add overdraft limit. Okay. And then for encapsulation, you can make interest rate and overdraft limit private by adding a single underscore. Sorry. So you can make them protected by adding this. This should be fixed. Actually, let me fix it now. So it protected by adding a single underscore and create methods to safely access them. So let's do this. So I don't want to make it. Okay, so let's do this. By adding double underscore and make this private and create methods to safely access them. I think this makes better sense. In savings account, create a method apply interest that calculates and adds interest using encapsulation to interest the balance is updated securely. For checking account, modify withdraw method to allow withdrawal within the overlap limit and securely update the balance. And then for polymorphism, override the withdraw method in both the new classes, and there's some instructions here how you should define them. And then finally, you should create a function, process account, which gets an object from each of these classes, and it calls deposit and calls withdraw for those functions. All right, so I'll give you a few minutes to extend the previous class example that we had, and then I'll go over the answer. All right. So let's get to this one by one. So first for the inheritance, so it's asked, we're asked to create two subclasses, and for each we're going to add a new attribute, right? So let's do this. So I'm going to define the init function here. That's where we define or initialize our attributes. Self, owner, we have balance and account number, right? And then we are also going to add interest rate. Okay, so there will be super init, and then from the super class, we're going to get owner, we're going to get balance and account number. But then we're also going to add the interest rate, which we're going to set equal to interest rate. Okay, so this is our initializer or constructor for this one. For the second one, we can actually copy the same, but for the last value, we have overdraft limit. And then we get all the same inheritance, but here we have overdraft limit, overdraft limit. Okay. Okay, so this was the inheritance with the additional attributes. So we have two subclasses which are both inheriting our bank account class, and these are the new attributes we are adding right here. So for the encapsulation part, make interest rate and overdraft limit private by adding a double underscore, and create methods to safely access them. In savings account, create a method applied interest that calculates and adds interest to the balance using encapsulation to ensure the balance is updated securely. In checking accounts, modify the withdraw method to allow withdrawal within the overdraft limit and securely update the balance. Okay. All right, so let's go back. Actually, there's also change to withdraw here. Override the withdraw method in both saving and checking account. Prevent any withdrawal that would drop the balance below zero. Allow withdrawals up to the overdraft limit. Okay, so let's actually create all of these things in one shot. So the first thing I'm going to do is I'm going to define the apply interest here. So apply interest. Oh, actually, first let's make this change: double underscore interest rate and overdraft limit. So let's do this. Let's make this a private attribute, and also this a private attribute. And if you want to get access to those, you can use let's call it get interest rate, which is a simple function to return self interest rate. Okay, so that's that. And then here we're gonna define a new function, get overdraft limit, which is an instance method, and will return the overdraft limit for us. So for apply interest, we're gonna basically define a new instance method. We're gonna get the interest, right? So what is the interest? It's self dot balance, and actually we can use get balance to get that. So self dot get balance times getting the interest rate. So we can use this function for that. Self dot get interest rate over 100. So this was the equation for interest rate, right? And then we're gonna self deposit with the interest, right? So we're gonna deposit that interest, which is calculated from here. And then we're gonna actually let's print interest applied this amount of dollars for interest, and then let's say the new balance is self get balance. Okay, so this is our apply interest function. And then there was a change needed for withdraw to check if the so what was the change we needed for withdraw method in both savings and income? Prevent any withdrawal that would drop the balance below 0. So I think we had something similar, but let's actually, I think this is just showcasing polymorphism. So it's just showing you that we can actually overwrite these functions or methods in subclasses. So if getting some amount, we can check if the amount is less than or equal the get balance, right? To make sure it doesn't fall below 0. If that's the case, we call the super withdraw function or method with the amount. Otherwise, we're going to print insufficient funds in savings account. Okay, so basically overriding that function to make sure that it doesn't go below the funds, available funds. And then for this one, we're gonna actually also, we have that overdraft limit, right? So we need to make sure the amount is less than or equal the get balance and also the allowed overdraft limit that we have. So we're gonna define withdraw and then given the amount. If the amount is less than or equal self dot get balance and also get overdraft limit, right? So in this case, we have the overdraft limit as well. Then self dot get, or actually self dot balance would go down by the amount, and then we can print this number of dollars withdrawn, and the new balance is this number of dollars. So that bit balance. Okay. All right, so these are the two subclasses asked to write in here, and then there's the last part which says create a function process account, and it gets an object as input. And the function should call deposit to add funds, call withdraw to test the specific withdrawal behavior for each account type, and then use this function to demonstrate polymorphism by passing in both savings account and checking account instances and observing different behaviors. Okay, so let's do it here. So I'm gonna define a new function outside of these two classes. So I'm going to call it process account. which gets an account, and this account is actually an object. And then it will, let's say, let's do what? Let's do a deposit of $100, and then let's withdraw. Let's withdraw twice, one with $50, so that we don't get any errors. And then there's another withdraw for $500. Okay, so this is what the function does. It gets some object from either of these two subclasses, and then it basically applies deposit and withdraw in this way. All right, so let's see if it works. So I'm gonna create these two objects from these two classes with these owner and the initial balance, and then the account number, and here's the interest rate for the first one, and then for the second one, here's for the checking, this is the overdraft limit. So when you create them, it says create account created for Alice and Bob, and then I just simply want to check how process account works for these two. So let's actually check the first one. So it says $100 deposited, new balance is $1,100, and then after withdrawal of $50, this is the new balance, and then after 500 withdrawn, this is our new balance. So that's fine. So for the second one, which started with 500 deposit, then we have 100 here, which makes a total of 600. 50 withdrawn, we get 550, and then 500 withdrawn, we get 50. So what if actually we didn't see the other cases? So if we had, let's say, 300 here, then yeah, so this is not correct. So we get a negative 150 after 500 is withdrawn. So we go back to checking. Actually, for some reason I didn't. So if the amount is less than balance plus overdraft limit, which is 200, so we have 300, and then 4 here, 3. Okay. So basically, if I go down to 100, I think now it will do nothing. So this is why, because I'm not writing the else here. The else should say print overdraft limit exceeded. Okay, so I think now it should work. Okay, so if that condition doesn't hold, it says overdraft limit exceeded. Yeah. Okay, so I think you get the point. Feel free to take a look at this and implement more functionality to it. But I think you get the idea. So this is mainly showing you how we can, how inheritance works, first of all, and then how we can encapsulate these things so that there's no outside access to these attributes. And then you also see the example of how we can use polymorphism to override these methods, right, for a particular use case. All right. So now we are going to change topic. So because we are done with the object-oriented programming concepts, so before I go to the next one, I want to make sure that there are no questions here. So I think the questions on the Q&A are addressed, but are there any other questions? All right. So from this point on, we are going to continue with the tools that we have been learning in Python. So now these are some additional tools that you may need in basically a day-to-day work. So I'm thinking about interviews versus practical use cases of these topics, and I feel like these are more helpful for your personal projects and daily work, not mainly for interviews, unless the interviewer is gonna assess how if you have any understanding of any of these topics. But maybe a little bit custom sorting could help, but these are not mainly for interviews, but for helping you, understanding the syntax and some additional topics that could help you. But I think whatever you need for interviews, for Python basics, we have already covered after covering this object-oriented programming. And this could be actually, you could be asked to write a code in object-oriented programming way. And then the other things you need to know are, those data structures that we learned, and iteration, like for loops, conditional statements. So those are the main stuff. The other tools that you may need to know to get it more advanced is to attend the data structure and algorithms class. But yeah, so I think we have all we need for now. So let's continue with custom sort functions. So there are two different ways to sort a list in Python. One is the sorted function. The other one is the sort or dot sort. So the difference is the way they get the input and what they return. So the sorted function takes any iterable and it will return a new sorted list. So any iterable, and the return value is a sorted list. And here's how the syntax looks like. You have sorted. This is our iterable. It could be a list or a tuple. And then we have a key, which defines the criteria for sorting. And then we have reverse to reverse the sort or not. Okay. And then we have the dot sort or the sort function, which modifies the list in place and returns none. Okay, so the key two differences. First of all, here sorted is not an in-place operation. It will return a value, but sort is in place. And then sorted will return a list, but dot sort returns none. Okay, so basically sort is specific for lists. So list dot sort will sort the list in place given the key and the reverse flag. All right, so let's go see some examples now. Okay, so let's first see the sorted function. So this is a built-in function in Python. You can simply use that without importing anything. So here's our list of numbers, sorted numbers, and then we're going to take a look at the original list of numbers. So as you can see, the list hasn't changed, right? So why? The reason is that sorted the number does not actually returns a new list, and it's not an in-place operation. Okay, so it's not gonna change the original list, and it's gonna return a new list. So if you do not collect the returned list, then it's not gonna give you the sorted list. So on the next example, we are gonna actually collect the sorted numbers in a new variable. Okay, and then you can see that our new list is actually sorted, right? Because sorted gives us a return, it returns a list. Okay, the next one is sort. So sort is basically one of the methods defined for the class of lists. And it's an in-place operation because a list is a mutable object. You can change it in place, and sort is one of those. So here we have numbers. I'm going to print numbers before sorting, and then I'm going to sort it, and then I'm going to print it after sorting. So you see that the same variable is changed, which means that dot sort is an in-place operation. Okay. If you try to print this thing, print numbers.sort, it will give you none because numbers.sort returns none. It's an in-place operation. It does not return anything. It just changes these numbers and sort the values in place. Okay. So the other difference between the two is that sorted is creating a new object. So basically, it's collecting more memory, right? So it's storing more memory, but dot sort is in place, so less memory is used. But sometimes you don't want to change the original list of numbers, so you will create a new one. Okay. All right, so some examples on how we can use key and reverse. So let's say we have this list of words. There's a list of a set of strings, and we're going to see how we can sort them based on different criteria. So if simply put sorted words, nothing else, then it's going to sort those words by default from their first letter, right? And if there was a tie, if we look at the second letter, and if there was a tie, the next letter, and all the way to the end until there's some breaker. If there is no tiebreaker, then it goes with the same ordering as the original list. Okay. But overall, sorted for strings goes with the alphabetic order. Now, what if I don't want to sort based on alphabetic order and I want to sort based on my own given criteria? Okay. So for example, I want to sort this list based on the length of these strings. I want to go with the shortest first. This goes first, and then the next one, and the next one. In that case, I will use sorted, and then here the list I want to sort. And then I have this key, which gets this lambda function, or it could be any other function. You can define a function outside of this, this sorted. And then the returned value of that function is the length of the input that it collects. Okay. So basically, we are defining the criteria to be the length of each of these objects. It gets that length. That length is basically mapped to some number, and then it corresponds that number to the object itself, and then it will sort this list of words based on that given criteria. So when I run this cell, then you'll see that the ordering is now changed based on the length of each of these things. Okay. Now, one other thing I want you to note that, so when I mentioned, I mentioned earlier that if there's a tie in the sorting criteria, Python would go in the ordering with the original order of the elements, right? So in this case, banana and cherry, they both have 6 characters and have the same length, right? So that's why you see banana goes first and cherry goes next. So because there's a tie. So if you want to go with multiple criteria, I will let you know how to do that just in a couple examples. So that's one thing. And then the other thing is that I could simply go with key equal len, because this whole part is giving us a function to calculate the length, but we already have that function in Python, so we can use that. Now, let's see what happens if I set reverse to true, which means I want to sort these list of values in reversed order. In that case, it would go with the longest string, and then between banana and cherry, because there's a tie, it would again go with the original ordering. So banana goes first and cherry goes next. Even if we are reversing the order, because there's a tie, it would again, even in the reverse, would go with the same ordering. Okay, so that's why you don't exactly see the reverse of this one, right? So because the function is the same, but we just set the flag to true, right? But after bananas, instead of cherry, we have banana. That's because we are going with the original ordering. And then the shorter strings go next. And then the last one is multiple criteria. So let's say in this case, I'm gonna sort the words based on the second character and then the first character, right? So first I'm gonna look at the second characters. So here A goes first and A goes first. A here goes first, right? And then because there's a tie between all of these things, then go and look at the second criteria, which is first letter. Okay. And then here, the first letter goes after these two. If there was a tie for all these criteria, then it would go with the original ordering that we had right here. Here, right? So banana goes first, bananas goes second after that. So that's why we see this one goes after this. And then after that, we look at the second characters. And then if there was a tie, we go with the first characters. Okay. So this is all we need to know for custom sorting in Python. Now I'm going to give you a couple exercises and I'm going to let you think about this and see if you can, you know, figure out these sortings on your own. So let me give you these two exercises in one screen. Okay. So I want to think about each of these. So the first question is, what is the output of these prints? So we have a few points, and the points are a list of lists. And then we are going to sort them in different ways. And then we're going to print the orders. So the way we are going to print them is basically after the sorting is done, we are going to get these first characters and we're going to join them and get a 4 character string. And that's how I want you to format your thinking, right? So in the output. And then the second exercise is combining a class and sorting. So consider the following class. It's a class of employees. Oh, actually, this is extra. We don't need that. So this is the class of employees. And then I want you to create the list of employees and sort the list based on employees' names. If there was a tie, order based on employees' ages. Okay. So now I'm going to give you a few minutes to think about these problems, and then I'll go over, I'll show you the answers and we'll go over that together. So I think we can move on to make sure that we are on time. So I'm going to now reveal the answer and then go over them together. So for the first question, we have 4 points and we are sorting them in different ways. So first, let me show you the right answer. So these are the answers to each of these sorting. So the reason we see 4 characters connected is because of what we're doing here. So we are getting the first element of each of these in a list comprehension. And then we are joining them with no space in between. So basically we are getting this first element and then this one, and this one. And we're joining them to make a 4 character string. And because we end them with a space, then we actually see everything in one single line. So now let's see why we get these things. So first of all, if you sort these points with no additional key or reverse given, it will sort based on the first elements, similar to strings, right? So it always goes with the first element. So we'll get A, then B, and then C, and then D. Okay. Now the second one is sorting based on a given criteria, which is the second element of each list. So we look at all these lists. So we have 1, 0, 6, 1. So 0 goes first because it's the lowest or smallest number. And then because we have a tie between these two, we go with the current ordering. So we have A first and then D next. And then we have 6, which goes last. So we have C, A, D, B, which is what we have here. And then for the last one, we have 2 criteria. So we have one, first we want to look at the last element. And then if there was a tie, we're going to look at the second element. And then we want this in a reversed order. Okay. So let's see what happens. So if you look at the last element first, 2 is the lowest, and then we have 2 3s, and then 4. So there is no if there was no reverse flag, A would go first, and then C would go last. There's no doubt in that. But between these two, because there's a tie for the last element, we look at the second element too. So we have 6 here and 1 here. So if there was no reverse flag, then we would have A, then D, B, C, right? Now, because the reverse flag is true, we go the opposite. So we had A, D, B, C. Now we have C, B, D, A. Okay. So we have C, B, D, A. All right. And then the other one is actually it's giving us this class, and let me run this class. And then it wants us to form these 3 objects. So I'm gonna do employee 1 is an object from the employee class with name John, and then department IT and age 28. And then I have employee 2, which has a different name, Sam. Department is banking, age is 20. And then the last employee is again John. It's in finance and the age is 25. Okay. So here's our list of employees, 3 objects. Now I'm going to create a list and then I'm going to sort that list. Okay, so I'm going to create a list of employees, which is going to include employee 1, employee 2, and employee 3. Okay. So here's my list of employees. And then, so if I print this list, it's going to give me this nice representation because of these 2 lines. Okay. Now, this is how the list is listed. But we want to sort this based on the names. So in a sorted way, these 2 Johns should go first. And then because there's a tie, this employee should go first because of their age. Okay, so I'm going to create another list sorted employees. And I'm going to use sorted. And I'm going to sort employees. And then I'm going to give a key to define the criteria for sorting. Lambda, a given x. Then I have 2 criteria. So the first one is the name of the employee, and the second one is the age of the employee. Okay. So I'm going to do that, and then I'm going to print sorted employees. So now I have these employees sorted by name, but here, because there's a tie, I would go with the age first. That means next. Okay. So actually, if you want to go with age the other direction, so the older employee goes first, then you can put a negative here. so that these criteria becomes negative. So this makes this negative 28 and negative 25, and negative 28 goes first. Okay, so that's how you can change the order for numbers. All right. Okay, so any questions here before we jump to the next topic? Any questions on sorting? All right, so if there are no questions, let me now show you how you can handle exceptions in Python. So exception handling is basically how to handle errors, right? So sometimes you're expecting errors and you don't want errors to crash the code. So exception handling is a proper way to basically prevent the code from crash and allow more graceful and managing the errors. Okay. So there are some common exceptions in Python, which you may see more often. Those are syntax error, type error, value error, and file not found error. But as you will see, these are all different types defined under the exception class in Python. And you can actually define your own exception in Python with your own messaging. So this is how the syntax looks like. You have try and except. Each of them is a block. Under try, you write a code that may cause exception, and under except, you write a code to run when the exception occurs. Okay. This is actually a subset of more complete syntax, which is try, except, else, finally. But usually you don't see else and finally in practice. These are defined for better code organization and a nicer look to your code, but it's not mandatory. So you can write try with your code, then if there is an error, it goes to except. But if there is no error, then it goes to else. So it's basically dividing those two different directions when there is and when there is no error. And then finally is always executed, no matter if there's an issue or not. You always, whatever you put under finally block, it will always be executed. Again, usually you don't see else and finally in practice, but if you want to make your code more organized, you can use that. All right, so let's get back to the code. Let me first show you some examples of some common errors that we have seen most of them so far, but let's actually see that in one place. So here, let's see an example of the syntax error. I'm missing a closing parentheses at the end, and I get a syntax error that your input is not complete. So this is one example of the syntax error. Here I'm trying to add a character to an integer without any typecasting. So in that case, I'm going to get a type error saying that you can only concatenate string to a string, not an integer. Okay, so this is an example of a type error. Another example is for value error. So now I have a string here and I'm trying to typecast it as an integer, but this is not compatible, right? So we learned that typecasting should have compatible inputs. So this gives us a value error saying that this is not the right literal for integer with base 10, the ABC. And then the last one, file not found error, is the case when you're trying to open a file, but it doesn't really exist in the specified directory. This is another error that it may occur from time to time where you're trying to read and write files. So we're going to actually go over that topic on the next section, how to read and write files. But let's say I have some text file here, non-existent file, for example, and I don't have any file as such. So when I'm trying to open it, and again, this syntax we're going to see in a bit later today, it gives us the file not found error saying that no such file or directory exists. Okay, so now let's see how we can handle some of these things. So exception handling in Python is done with try and except. So let's say we have these two variables, for example, and if I try to print A over B, because B is a 0, we cannot divide by 0, we get this 0 division error, right? Now, to show that I'm aware of such scenarios, I put my code under try, and this is a code block with indentation, right? And under except, I print cannot divide by 0 because I know if there's an error here is due to division by 0. And then I'm going to print completed after this try and except block. So in that case, now instead of having the code crashed, I get this message in the output, and then my code continues, right? So let's see another example. Okay, so let's say I have a variable here, x, and it's got a value 2. I'm gonna add 3 to a variable named y. So this is an issue, right? Because y is not defined yet, right? And then I'm gonna handle this exception. But now I have a new syntax to show you. We can actually get the error into a variable, and then we can, kind of play with that variable. So we can write except, then exception, which is the class in Python for handling all exceptions, as some name that I want to pick. So I want to pick the exception happening here with some name. And then I'm going to print some message, and then I'm going to see what's actually this object that I get here. So here it says, so first of all, it shows the message, my custom message. And then the type of this error, it says it's a name error. And then if I print the message, it says name y is not defined. So basically, if I wanted to get an error, this is what I would get. So this is the type of the error, and this is the message of the error, which I'm getting from these two. So if you write except exception as some name, then you can actually get the content of that exception, and then you can actually print them without having your code crashed. Okay. And then this last line is always printed because it's outside of this try and except, and your code keeps working, and then it will be executed, right? So the last line. Okay, so another example. So let's say now I have this x, and I try to add it or concatenate it to this string. This is also an issue, right? So this was a value error or type error, sorry. So it says this is a type error, and then this is the error you would get if you were running into an exception. Okay. But now let's say the other scenario is that there's no issue, right? So now let's say after defining x, we're going to add 2, and then we're going to print it. Then we don't see any of these things because our code has no problems. And then right after try, we skip this except part, and we print this line. All right. So the other thing you can do, and this is really helpful in making sure that you put all the flags and make your code complete, is to actually raise an error. So whenever needed, you can use this raise keyword to raise an error, right? So for example, I have a use case that I am defining a function divide, and I know that when b that the second parameter is equal to 0, I know that there should be an error when dividing these two, so I explicitly raise that to make sure that the code stops right there. So there are so many instances that you may need this in a real world scenario. One of them is that you may actually have some class function. You write a class, and then for the function, you definitely need an implementation if someone is using that class. If they don't overwrite that function, you can raise some exception saying that your custom message, right? So in this case, we raise, this is the exception, class in Python, and then some messaging of your choice, right? So I define this function, and then if you try to divide 10 by 2, there's no issue. It will return this value for you. But if you try to divide 10 by 0, it would raise the exception that you defined, right? So it will raise the exception with the message of your choice. Okay. So now let's see an example with else. So let's say I have a try, and this example is showing you that you can have multiple accepts. So for different types of errors, you can have different messages. So here for zero division error, I have one message to show. For value error, I have another message to show. And for exception, for any other exception, I have a general message. And if none of these cases, I mean, if there's no issue with the code, then this else will be executed, right? So if I go back here and try to divide 10 by 0, then I'll get this message because this is the type of error that I'm going to handle. It's handle the exception. So for this one, I don't have anything specified here. So this is a type error. So I get this overall exception, right? So this is handling a general case. And then in the third example, this is a value error. And for value error, I have a special message as well, right? And then if there is no error, then I just get this else block implemented, right? So this else block executed. So we can have multiple accepts, but only one else. And then here's the full picture with all blocks. So you have try, except, else, and finally, right? So here we also have a new keyword, assert. So it's similar to raise, but what it does is it will check equality, right? So what comes after assert is a Boolean. If it's true, then you're good. If it's false, then it will raise an error. So it's good for checking, for example, at any point in your code, you want to check if a flag is working fine. For example, if you have two matrices that you want to check their dimension, and so you want to make sure their dimension is equal for some downstream operation, then you will put an assert and check their dimension and then continue the code. So I'm going to get an input from the user, and I want them to enter an even number. And then I check here. If the number is even, then we're good. If the number is not even, then this line will raise an error. And then if there's an error, the except block will say this is not an even number, and then we go to finally, right? But if the input from the user is even, then we're good. And then we're going to find the reciprocal of that number, and then we're going to print it, and then we print finally. Okay, so let's see an example. So if the number, let's say, is not even, so I'm going to enter 5, then it says not an even number and run completed. Okay. Now, if the number is actually an even number, it will find 1 over that number, or the reciprocal of the number, and then it will say run completed. And then the last example is to write a custom exception. So if you want to write your own custom exception, then you can simply inherit from the exception class in Python and put your own message in the constructor. Just add your own message. Okay. So I define this class here, and then later in my code, I'm going to raise this custom error that I define right here with my own messaging, right? And then I'm going to get the type and then what the message says. So it says the type is a custom error that I define. You can change the name. And then this is the message that I assign to that error. Okay. Any questions for custom, exception handling? All right. So if there are no questions, then let's take another break. And then after that, we're going to go over file handling and JSON module. So I think we are good on time. We may need 15 or 20 minutes on top of the 4 hours, but we should be able to wrap up the class before 4.5 hours, I would say. All right, so let's take another break, and we'll be back in 10 minutes. All right, welcome back. So we're going to continue with the topics. We have 2 more, file handling and JSON module. So for file handling, it's just the processing of reading from files and writing to a file. And it's important because it's kind of a connection of your code with the external sources, right? So if you want to generate reports and share those files, you can write to files. So in this class, we're only going to see that the example of text files and JSON files. But in the upcoming class, you'll also see examples of CSV files and other types of data like NumPy. But then I think the more practical reading and writing use cases are the ones with different cloud providers, because usually now for security reasons and for the scale of the data sets, most of the companies are actually working with real data, which is large in scale. And to read files from cloud, or to write your files to the cloud, then you need to basically have a set of instructions. So each one of these platforms, like GCP, the Google Cloud Platform, or AWS, or Amazon Web Services, or Azure from Microsoft. So these come with their own set of instructions on reading and writing, and there are actually extensive documentation for each. So that is not the scope of this class, but what you learned today, you can think of extensions to those platforms as well. So for the text files, we have different modes when you're trying to open a file. You have the read mode, you have the write mode. You actually define these modes with these characters inside the open function that we will see the syntax shortly. And you can also add guardrails. For example, if the file already exists, if you use the X option, it will actually give you an error saying that the file already exists. And if you want to append to the already existing item without overwriting it, you can use the A option. Otherwise, the W will basically overwrite whatever you have. It will erase it and then create a new file from scratch. So here's the syntax for opening a file. So use the open keyword and then the name of the file in its directory. And then there will be a comma and then the mode of opening the file. So in this case, we are reading the file, but you can also write it or use X or A for the other options. So after you open it, you assign it to some variable. in this case, we name it file, and you can read the content using the .read, and you can then print that content. And then after you're finished with that, you need to close it to make sure there is no, you know, accidental overwriting or any data leakage later. So it's always recommended to close the file after you open it. But if you, just to make sure that you don't forget that, we have another syntax that uses with keyword, where you use with open as file, and then inside this code block, whatever happens after that, this open file will be closed. Okay. So for reading files, we have different options. Read will read the entire content of the file. And then read line reads one single line from the file and goes to the next line. And read lines read all the lines in a text file and returns a list of each line. Okay. All right. So we also have options for writing files. If you want to write a given string or whatever you have, the contents to a file, you can use the write function. Or if you have a list of lines and you want to write all those strings to a file, you can use write lines. Okay, so here, for example, I have a few lines, and you see these \ns are special characters for new lines, right? So it means go to the next line. And then I'm gonna open this text file in write mode, and on this output.txt, I'm gonna write these things line by line. So I can use file write lines to do this in one shot. Okay, so let me show you some examples now. All right. So first, I'm going to open this file. I've shared the link to this file with you. It's a small file with 3 lines. Let me share the link another time. Sample test1.txt. So I just shared it in the chat with everyone in case you want to try this code with me. So I'm going to open this. So and after I open it, you can see the type is a new one. So it's input output wrapper for text. And then I can get the content. I can use file.read and get the content of the file. And here's how the content look like. So the type of the content is a string, and then the content has these 3 lines. Okay. So after I'm done with this file, then I should close it. And then if you try to get the content, it will provide a value saying that after closing a file, you cannot access. So if you want to do this automatically, you can use this with keyword. And then when you use with, after you open the file, and then you have to use as some name for the variable, then you can read the content. And then after that, you don't need to worry about closing the file because it happens automatically under this line and this block. So the thing is that there's no change in the performance. Nothing really is different. The only thing is this with will take care of opening and closing the file for us. Now, if I want to use read line to read the lines of the text one by one, I can open it, and then the current line, I can get it with file.readline. I'm going to print it, and then after you call this read line, it automatically goes, it takes the pointer to the next line, and then you'll read the next line. Okay? So if you can actually put this in a while loop and go line by line until there's no line, and you can actually break out of that while loop in that case. And you can go line by line. All right. The next option for reading lines is read lines. which will read all the lines in the file one by one, and it will create a list out of those lines for you. So here's the list. This is my first line, and then there's this \n, which means the next line is on the next line in the file. Okay. Now that you have a list of strings, you have access to all list methods and all string methods for any string manipulation or any text manipulation. You can explore through the list, etc. Now, for writing, we have the W option to write the file, and if the file exists, it will overwrite the file. So the syntax is the same. We just changed the mode, and then here the file name would be the name of the file which is going to be created. So file.write, and then this is my first line, and then there's a \n, and then my second line, right? And then I close the file. Now I want to read the content, so I'm going to open it again in the read mode, this test2 file, and you see that this file is created in the same directory as the other one. So this is the directory for this class. This was test1, and this test2 is also created. Okay. Now I can overwrite that. So if I write this file again with the same option, and then I change my writing content, then if I read the file again, you see that it's overwritten, and the previous content is removed. Okay. Now if I use the X option and I try to write on the same file, I'll get an error which says this file already exists. You cannot write on it. Okay. And then if I use A option, then it will append that new content to the previous content we had. Okay. And the last example here is write lines. When you have a list of strings, you can actually put them on a file. So it says test3 is the name of my file. It's a text file. And I use write lines to write these lines one by one on this file. So I've created another, let me actually go here. So you see that now test3 is also created here. Yeah, this is how it looks like. All right, so now I have a class activity for you. I'm going to give you a couple minutes, and then I'll show you how to solve it. So we have 3 parts. First, I want you to create a new text file named myfile.txt and add these lines in 2 separate lines. Okay. And then I want you to append a new line to that at the end. And then lastly, I want you to iterate through lines, and at each iteration, I want you to find the location of the word Python. Okay. So there's a hint that you can use the index function. So you remember when we were learning about strings, and then the specialized methods for strings, we had this index, which we can find the index of a given substring, right? So use this function to find the index of Python in each of those sentences. I'm going to give you a couple minutes here. All right, so let's go over the answer together. Okay, so first I'm going to create that file. Let's say I have a list of lines, and it's going to be produce a log Python, and then the next one is Python is my favorite, right? So you can either add the \n here, or you can add it while you're writing the file. So actually, let me show you the other option because we have seen the other one. So with open my file dot text, and with the write mode as file. So this could be any name, right? So it's not, doesn't have to be file. For line in lines, so for each of the lines, I'm gonna write the line, and then after each line, I'm gonna add a \n. I can also do it here, or you can actually put your \n here. Both will work fine. So the only thing is that even after the second line, this will also add a \n, which maybe you don't want to have an empty line. So let's do this. Okay, so now I'm gonna see how the file looks like so far. So I'm gonna say with open my file.text in the read mode. I'm gonna get the contents, file.read, and then I'm gonna print the contents, right? So this is how the content looks like so far. Now, I'm gonna append a new line, which says, yes, Python is great to the end. So I'm gonna open this my file again, but this time in append mode or A mode. And then I'm gonna write this new content to that file.write this new content. Okay. Now let's see how the file looks like now. Okay, so actually I need this to make sure that it goes to the next line. To make sure that happens is I can actually put, oh, actually, let's do this. Let's write this from scratch, and then here I put a \n, and here's how it looks now. Okay. All right. So the last question is iterate through the lines, and at each iteration, locate Python and then report it at the end. Okay. So let's open this my file again, and I want it in read mode as file, and I'm gonna add all the lines to a list, which I'm gonna call lines. So I'm gonna use file.readLines, right? If you remember. Now this is how lines look like, right? So this is our lines on this file. Now I'm gonna define a new list. I'm gonna call it indexes or index. So this list is gonna collect all those indexes for Python on each line. So I'm gonna go through a for loop for line in lines. We're gonna find Python using that dot index. So we are gonna find the location using line dot index of Python. So this line finds the location where this substring starts, right? For example, in this one, it starts from 0, 1, 2, 3, 4, 5, 6, 7. And in this one, it starts from 0. Here we have 0, 1, 2, 3, 4, 5. And after we find that number, we are gonna collect it in our list. So index.append location. Okay, and then this is how index looks like. So we have 7, 0, and 5. These are where these substrings happen. Okay. Okay, so any questions on file handling? All right, so if there are no questions, we have one more topic, JSON module in Python, which is kind of related to file handling. So JSON modules, first of all, what are JSON modules? So it stands for JavaScript Object Notation. but so the name comes from JSON, JS from JavaScript, but it's not really a language specific file, so it's language agnostic. It's a lightweight and data interchangeable format, and it's very it's highly readable because as you'll see, it's a set of key value pairs very similar to dictionaries, and usually people write meaningful names for those keys and values so that it's more meaningful. It's lightweight. It's a great way if you want to collect huge amounts of data, because it just creates this key value pairs, and it's a string file. Basically, JSON is a string object which is saved onto some file and stored somewhere, right? And then it's easy to parse and generate because, as you will see, because of its particular key value pair structure, it can be converted into a Python dictionary, and then from a Python dictionary, you can serialize it back to a JSON file. And then it supports various types. So you know that keys in Python should only be immutable, but the values can be of any type. So that is the same for JSON files. So let's see how it works. So before that, there are 4 main functions that you need to know about if you want to use JSON module. So first of all, JSON is a module in Python. You have to import it. And then you have dump and dump s for serializing a Python object to a JSON format. So dump gives us a JSON formatted file. It's basically called a JSON file or .json. And dump s will give us a JSON formatted string within our Python code. Okay. And then we have load and load s, which do the opposite. They deserialize a JSON data from a file or from a string into a Python dictionary. So JSON.load deserializes JSON from a file. Load s does the same thing from a string. Okay, going back to the notebook. First of all, we need to import JSON. So we'll import JSON. And then here we have a dictionary, right? So I'm going to call this dictionary person. So we have some information about this person: name, age, city, if they have children, and titles. Okay, so this is our dictionary. And then I'm going to serialize this to a JSON string. So I'm going to use JSON.dump s or dump string. And then the input would be this dictionary. So JSON dump or dump s gets a Python object and creates a JSON format. It could be a file or it could be a JSON string. So running this line will give us this person underscore JSON. And if I show you the type, it says it's a string, right? Because a JSON format is basically a string. So what is the difference between JSON and other strings out there that we have seen? Because of the specific format, right? So because of this format, we can also put it on a file. It's lightweight. And when we bring it back, we can actually read it as a Python object, as a dictionary. So here's how the JSON string looks like. And if you want to make it look better, you can actually use other settings. So you can use JSON dumps person, but you can also use indent for indentation, separators, and you can sort the keys based on their alphabets, and you will get something more readable. So you see that these separators have changed from comma, we have changed it to semicolon, and then for these colons, we now have these equal signs. So it's up to us. It's highly customizable. But this was an example of from Python to JSON text or JSON string. Now we're gonna serialize this into a JSON file. So we have the same person Python dictionary. Now we're gonna open this person1.json file, in the write mode as file. And then we're going to use .dump in JSON to dump this dictionary onto this file, which basically takes this dictionary and creates an object like this, a string, and places that string on this file in our local directory. So if I go back here, you'll see that now I have this JSON file added here. Okay. Now, how to do this the other way? So now let's say I have this person1.json and I want to read it and make it a Python dictionary. So I read it on this line, same as the previous examples. And then I use json.load to get that file and read those data and put it on this loaded person, which is now a Python dictionary. Okay, so the type of that object, it says it's a dictionary. And if I print it, it gives me this, which is not a string anymore, but a dictionary. Now, because it's a dictionary, you can get access to the values by calling the keys, right? So this is what we learned last week. Now, how about deserializing a JSON string? So instead of a file, we have a JSON string within the code. And then I can use load S for loading a JSON string to load this JSON object. And then we have a dictionary, and then same, right? So then this dictionary we can get the keys and values and everything. So for example, if I remove one of these commas, right, then if I try to load that, I'll get an error saying that we expect this delimiter. So you need to make sure that everything is working fine when you're trying to define a JSON file. It should be syntactically correct. Okay. All right. So that was our last example and our last topic. Any questions on JSON files before I wrap up? So there's a question that do we always with dictionary data type while serializing and deserializing JSON? The answer is yes. So because of the specific format of a JSON file, the only object in Python which can be mapped to and from these files is a Python dictionary, because we have key value pairs and there's no other data structure in Python which accommodates that for us. Okay. Any other question? All right, so if there are no other questions, then going over the list of topics we covered today. So we started the class by covering some concepts from object-oriented programming. So this was by no means a comprehensive lecture on object-oriented programming, because if you take a look at computer science engineering courses for undergraduate and even for graduate school, this is a concept for one full course. So we could basically go over the fundamentals of how to write a class and some concepts that we learned, like inheritance, encapsulation, and polymorphism. But now you have the basic understanding of how things are, basically how the syntax looks like. And if you want to learn more, feel free to do so. But my suggestion for you is it's a never-ending concept to learn. So the way you can actually learn more strategically is to work on different projects. And if you happen to look at a code from somewhere in industry, then now you know that this is a class. If you don't understand a part of it, then you would just go and search for that, right? There are so many other decorators which we couldn't cover in this class, or so many other magic methods, for example. Feel free to take a look and if you're interested, that will be interesting to know. So other things we covered: custom sorting in Python, exception handling. So some other tools to help you with your coding, especially for day-to-day, daily tasks. Not that much for interviews, but just Python usage. And then the last part of the class, we covered file handling, how to read and write files, and then how to work with JSON module in Python. So this is pretty much it. So the first 3 weeks is gonna cover all the foundation that you need for Python programming. Again, this is not an advanced course. So this first course is as a fundamental course to get you prepared for the next coming classes. So the final week of this series will be Python for machine learning, which introduces you to some modules which are used for scientific computing, and then tabular data manipulation and visualization using matplotlib. So there are 3 main libraries that you're going to learn in the last week, which is kind of a segue to the next few courses in this series, which are on feature engineering, data preparation, and basics of data science. And from there, you'll move on to more advanced courses. One more thing is, if you want to take these knowledge from these 3 weeks to the next level, and especially getting more prepared for interviews, I would highly encourage you to take a course in data structure and algorithms, because that's how you can make your codes more concise and more efficient and optimal in the sense of time and memory complexity. So that's how people are expecting you to code in industry, especially if you're enrolling in an engineering position. So that's really important. Cool. So we are gonna have class on Thursday for assignment review, and then next week, the next Sunday, there will be the last session for this series. So I will be there for assignment review sessions, but I cannot make it next Sunday for the final class. So I'm gonna see you next Thursday, and then the Thursday after that for the final assignment review. All right, thank you all for joining the class. And if you have any other questions, I'll be here for a couple more minutes to make sure. Otherwise, see you on Thursday. Thank you all. All right, so I see there is a hand raised. Kari, please go ahead.
Hey, how's it going? Can you hear me?
Hi, yeah, I can hear you.
Okay, cool. So I was sort of wondering, how much in a hypothetical like job regarding dealing with AI and development in that field, how much of it is just using the modules correctly that are sort of these like prepackaged data handling modules versus creating and coming up with complex networks in Python that connects the dots for like LLMs or something. I don't know if this is like this question makes sense. I don't because
So
I
the
feel like there's a whole
question.
lot of ocean I don't know. Right.
So I think it's a very general question. We can probably we can break it down. So I think the main question you're asking is, kind of shifting from these data science introductory level courses to more advanced large language models, or computer vision and natural language processing applications. So hard what we are learning here and in the next few classes, these libraries and these kind of things, how they work and how they're applicable when we get more advanced. Is that your question? Am I hitting the right question?
Yeah, sort of, but also how much of the yeah, let's start there. Let's start there.
Yeah, so my answer would be, I mean, the things are this is kind of everything is evolving, right? So maybe large language models 5 years back, you wouldn't have access to many of the libraries that people are using these days 5 years ago, right? So of course, when you get to that realm of those kind of complex transformer based, deep neural network uh, and those kind of models, then you probably would need some more advanced libraries. For example, even using PyTorch, even PyTorch is evolving on a daily basis. They're releasing new versions, and they have this Lightning model now. So for sure there are libraries when you get more advanced, both in this series and then later on. You'll definitely need to understand more complicated libraries and learn new things. But this is kind of a basis for you to get started, right? So I mentioned libraries like NumPy, Matplotlib, or Pandas that you're going to learn next week. So I still use them almost on a weekly basis, right? Because that's independent way of visualizing things, right? So I use Matplotlib on a daily basis to plot some stuff, and plotting and reporting stuff is always a big part of a machine learning engineer role. So that's not really related to whatever library we need for more complex algorithms. Or for example, for pandas, you sometimes need to manipulate some tabular data, uh, and you know it doesn't really have to do anything with those large language models, because my use case in this case is much simpler, and I have to use pandas to make some changes to my table, right? So we cannot say you will directly use these libraries later on when you're getting challenged with advanced natural language processing projects. But I would say these are always things you have to know. These are the fundamental things that you need to know, which could come handy at any point in your journey. So yeah, I would say
Okay.
this is something evolving over
To sort
time.
of point the direction that I'm trying to get at here is how much of
Uh-huh.
the skill of excelling at these roles lies within understanding the entire use case and ability for like use of these modules versus say like when we look at the something of the skill as when we look at um the optimal algorithm for like our homeworks and stuff like that kind of skill as to like um being in the best like O notation and stuff like that. Like which how much of it is like, making sure that you optimize your time complexity versus
Yeah.
knowing how to use these modules correctly.
Yeah, so I would say it depends on the algorithm, but usually when you get to very advanced and complex algorithms, then you'll run into issues if your code is not optimized. Actually, I have quite a few examples in my mind that if your code is not optimized, it's so difficult to actually run some of those algorithms, especially when it gets to big data, right? So the scale of the data which is required for those applications, you definitely need to come up with some optimization and some techniques to make things distributed and with parallelism in your data, and data handling. So I would say optimized code and efficient way of coding is I would say, um, how do you call it, is necessary but not sufficient, right? So it's a necessary part of your machine learning engineering uh, habits, but it's not sufficient because you need to build more skills on top of that. So that's
Okay.
that's how I would define it.
Thank you.
Yeah, cool. Yeah, thank you for the question. So I see there's another one on the Q&A. Going forward, next classes, will we still be asked to do more data structure exercises the way we have been doing till now? That would help to practice more. Um, so Neomani, so I see your question, and I'm not really sure. So I have taught some of those courses before, but in none of those classes the focus is on data structure exercises, because those were data science courses, and in those classes, we have only 4 hours, and we need to make sure that we cover the right set of topics for that 4 hours. If you're interested in data structure exercises, then I would highly recommend to take a look at the curriculum and or ask operations. There should be some data structure and algorithms courses which is uh, just on this topic, and with the right expectations set for those classes, with a lot of examples and tons of assignments, which will help you a lot for those interview questions. I see there is a hand raised. Stephanie, please go ahead. Stephanie, I think you should unmute first. I don't see you have. I think you're muted.
I didn't have a question. I accidentally hit that. Sorry.
Oh, no worries. No problem. All right. Any other questions? All right. So if there are no more questions, then so first of all, I will share the completed notebook on the same link which was shared, which you should have access, and then I'm gonna see you on Thursday. Thank you all, and have a good rest of your Sunday.